because we want to look at a problem involving Newton's second law. So to do this problem, we're going to assume that we have a car, and our engine is capable of applying a force of 1,000 newtons when we hit the gas. Now, if the mass of our car is 500 kilograms, the first thing we could say is, well, how much acceleration can our car produce? Well, remember that the second law said that F is the sum of the forces, or F net, we'll call it F net. F net divided by M equals A. Now, when we look at this, we say, well, we only have one force, that's the force on the car. That's the 1,000 newtons that the engine provides. The mass is 500, so our acceleration is 2 meters per second squared. We can check the newtons, limit the units, because this has units of newtons divided by kilograms. And we said that the unit of the newton is a kilogram meter per second squared. So when we take that and divide by the kilogram, that cancels the kilogram, and we're left with meters per second squared. So our units are good. Now we can continue our question and say the following. Let's say now we put some people in our car, and let's just say we add 4 people. And let's say each person weighs 50 kilograms. Now what's the acceleration of our car? Well, our force is still the same. Our force is still 1,000 newtons. But our mass has now changed. It's the 500 kilograms plus the 200 for our passengers, because of 4 times 50. So we now have 700 kilograms of mass. So now when we look at the net force, our net force is still the same. It's 1,000 newtons. But now we have to divide by 700 kilograms. So that leaves us with an acceleration 1.4 meters per second squared. And we see that our acceleration gets smaller because we've added people to the car. The engine isn't any stronger. It's still only capable of putting out 1,000 newtons. We have more mass, so our car's acceleration capabilities have decreased. So this is just an idea of looking at some acceleration based on some input forces and knowing our masses.